Hello everyone and welcome to this video that I want to show you some features that I liked in the EMAG software. As you can see in the previous videos of the channel, I'm using different finite element software for motor design. Each of them have their own pros and cons, and some features on each of them will be very useful in different simulations. Now I'm testing EMAG software from EMWorks company, and during the simulation of this axial flux machine, I found some features that were useful and I haven't used them in other software. Maybe I couldn't find them or maybe they don't have this option. EMAG from the EMWorks is a general purpose finite element software that has a 3D environment to model different applications, and it is CAD agnostic. The software can be used to simulate electromotors, actuators, induction furnaces, bus bars, or even a simple fuse to solve the electrical field or magnetic field distribution and extract the results. The workflow of the simulation is similar to other software. First, you have to create the geometry, then you have to assign material for each part, and we have to dedicate properties of the materials related to our simulation, if it is magnetic simulation or electric field simulation. Then assign boundary and conditions. You have to dedicate the excitation and forces and torques. And in the next level, if you have a motion coupling or circuit coupling or thermal coupling, you have to set them here on this step. Meshing the geometry will be done here in this step, and then you have to analyze and extract the results. Now let's talk about which features attracted my attention. To have a better view, let's hide the top rotor and magnets. It is a slotless axial flux machine. These coils can be printed on the PCB. And let's hide the coils too. I want to show the magnets of this rotor. I have to select the coils too to be able to hide them. Now we can only see the bottom rotor and its permanent magnets. The first feature that I want to talk about is permanent magnet direction. Like any other software, you have to dedicate the coercivity direction or magnetization direction of each magnet. So you have to right click on the part and select the coercivity direction. You can use global or local coordinate system and choose the cylindrical or Cartesian or spherical systems to set the vector of the magnetization. But very small feature here, show the preview, is very useful in many simulations because in other software that I have worked with, you have to analyze the simulation, and after a long time of analysis, you could draw the magnetic field to be able to see the magnetization direction, and if you made it correct or you made any mistake dedicating the magnetization direction. But showing the preview of the direction will help us to understand if we set all the magnets correctly or not. I will select all the magnets and right click on them, choose show symbols. Before the analysis, we can check if all the magnets are set correctly in the pre-processing step or not. We don't need to analyze the simulation to draw the field. We can check them at the initial step. As we can see, all magnets have a correct direction. Now let's hide these symbols to have a better view and move to the next feature. It is in the excitation part. When you want to set the input voltage or current, you have to assign coil to the excitation and set the parameters of the coils, entry port, exit port, and the input source. When you want to dedicate the source parameters, This preview window again will help us to reduce the risk of making any mistake in the pre-processing step. We have different types of current source here, like DC, sinusoidal, pulse, and user-defined source. I will choose the sinusoidal current source and set the parameters of this source. For example, if I add a DC value as the offset of this source, I will see the changes instantly inside the preview window. You don't need to simulate the project and plot the current of the windings. You can see the shape of waveform right here. Let's make back the offset to the 0 and change the phase shift of the waveform. When we are creating a, for example, 3-phase system, it's very important to know the shape of the source and its initial phase. It will be even more useful if we have parameters like damping factor. Let's increase the end time to have more cycles and change the damping factor to see the results. If we want to inject the current or voltage gradually to the windings, this damping factor will help a lot. And with this preview, we will understand the speed of changes. I will increase the damping factor, for example, to 20, and that's a good start for injecting current. So first two features were in pre-processing step about preview of the source and preview of the magnet direction. The next feature that I want to talk about is in post-processing and extracting the field results. Let me show all the parts and plot the magnetic flux density on all objects. It is the field distribution on all parts of the simulation, and the feature that I found very useful here is this option, section view. In other softwares that I worked with, you have to draw a surface and then you are able to plot the field on that surface. But here, without plotting any additional surface or object, you can easily have the cross-section view of all fields by just moving the surface of the cross-section. You can change the plane by this option and have the other views from different planes. Let's have another one. And now we are plotting the field in ZY plane. I think it's a useful option because in some simulation we want to see the exact value of the field inside different parts. And with this option, we don't need to draw planes or lines in the pre-processing steps. I hope you enjoyed this video, and if you have experience on other software and you know how to plot these field cross sections or magnetization preview on them, please share your knowledge in the comments. Please don't forget to hit the like button if you found this video informative. Thanks for your attention.